Hello and welcome to the observations on outline of cotton spinning. In this unit number 2, we are going to refer to the properties of the cotton fiber. In the earlier unit, we did see about some definitions of the different fibers, their classifications, the yarn classification, and some points about the filaments. So let us start because the properties of the fibers they play very vital role, and amongst this the cotton fiber being the important fiber, we are going to see some of the influential properties of the cotton fiber on the yarn spinning and overall the spinning process in general. So I am Professor S.G. Kulkarni, Associate Professor, retired from the DKT's Textile and Engineering Institute, Chalkaranji. So let us start about some points of the properties of the cotton fiber. Now, prior we go to the observations on the cotton fiber properties, let's say understand what exactly is the cotton fiber. In general, how it is grown, how it is cultivated in different parts of our country and all over the world also, and what are the primarily the properties of these fibers. So cotton primarily is grown in dry tropical and subtropical climates. So certain climate has to be there for the cultivation of the cotton fiber. So in our country, in different parts where the climate is slightly on the hot side, there usually the cotton plant is grown. Let there be a scanty rainfall, doesn't matter. The water requirements are slightly say less required in case of these fibers. So that's why they are grown in different areas where this particular suitable climate is there. Now, as we have seen in the classification of the fibers, this cotton fiber say stands on the natural side, and mostly it is a seed hair. So cotton seeds are usually planted in the ploughed soil in the farm, and then certain ridges are formed, certain particular shapes are given, and in these ridges in certain seasons from March, April, or during the August, April, August, etc. in our country, these seeds are grown. These seeds are sown, and then further growth occurs about this particular plant. These seeds are planted 1 to 10 centimeter deep in the ridges, 1 meter apart, because usually these plants grow slightly horizontally and vertically they attain certain 3 to 4 feet height. So that's why the certain gaps are required to be kept, and that is also required for the further process when the cotton say bull is fully developed and it is required to be picked from the plant. During this process also, this distance what is kept, that particular distance will be helpful in movement of the people or movement of the machine where mechanical picking is done. Young plants are pushed, they are grown in the soil 8 to 12 days. Within this period normally this germination process will occur, and then further plant growth will occur. There are certain steps in growth of these plants, and finally when the pod is obtained or the bull is there, opened bull is there, from which the fibers are normally picked up, this development will occur there. So usually flowering will occur within usual period of growth will be between 45 to 90 days. So 2 months after the crop has been planted, the blooming will regularly occur and the growth of plant will take place first. Then the green bud that will develop on this plant, the flower bud will say develop on these plants, and further the flower will come out of these buds, which is having a sort of a yellowish color, yellow color flower will be there, and then this will turn into a pinkish color in the further days, and then the after the third day of the flower has fallen, the pod will be bull will be appearing there. Then in these bulls, within these bulls, which are still they are closed, naturally they are closed, in these say bulls, the fibers are growing within. So this will occur within 1 or 2 months. The immature seeds, they are formed further in these bulls. They grow rapidly, and then 40 to 50 days this process will take place, as I have say earlier stated about this one. And then the fibers will start growing on each seed. Usually there are 20-30,000 fibers on an average. So one bull may contain around 1,50,000 fibers or so. So this is the general description of how the fiber development is taking place inside the bull. So within certain steps these processes are occurring. This is what is say depicted in this particular the diagram as you are able to see on the screen. So first is the seed is sown, then 1 week of the seeding, 2 weeks of the seeding, the flower will turn, then it will say turn into a bud. Then after that bud has say developed in a proper fashion, 8 to 10 weeks, then the bull will be there, a green bull will be there. After 18 to 20 weeks, the bull will be flourishing. It will open in a natural process, and opened bull which comprises of the seed cotton that will appear on the plant. So this is how in sequence all these different steps are there. On the plant itself, normally on the top side of the plant the bulls will get opened first, then the middle rows will be getting opened, the bulls will get opened, and then the lowermost bulls will get opened. So in phases on the plant itself the growth is occurring. So in stages all these things will happen within 45 to 90 days, something like that. So when the seeds nearly they are ripening, the bull burst opens, and then the cotton hairs project, they come out of the seed. So these are normally called as seed fibers. These are seed fibers which is a fluffy mass, usually accommodated in 4 sections, as it is shown in case of this particular diagram. So this is a fully opened fiber bull. Now this is having lot of seeds, thousands of seeds are there in this one, and then thousands of fibers are also there in case of this bull. Now this kind of bulls are ready for picking. So once the bulls are ready, the maturity the fiber is gaining, that particular process is slightly different than this one. So once the fiber is coming protruding out of the seed, then the development has already started in case of one single fiber. This is a bull which is comprising of a thousands of fibers, as we have earlier stated. So this is how the whole process is there. Still there are certain properties which are required to be attained, they are required to be obtained by these fibers, then they are ready for picking, and then they are passed through certain further processes either on the field itself. Certain processes are conducted in certain industries like the ginning industries, where the seeds will be separated, and a lint cotton which is ready for spinning in the spinning department of a textile mill, that will be ready after certain period of time. But there are stages of growth of these fibers, stages of growth of the plant, stages of growth of the fiber. They are parallelly they are taking place. These are accomplished when all these things are happening within a certain specific period of time. The fibers now complete their ripening. Ripening is nothing but maturity. As it is there, this natural phenomenon is there in case of say fruits or some other related natural products, the ripening is required to be there. And this particular thing, by manual inspection, the farmer can understand whether the ripening has taken place or not, or there are certain testing devices which can decide this thing. Of course, testing process will be a totally different part, which is usually required to be carried out where the collection center is there for the cotton bales, where all these say bulls are collected together, they are made into a converted into a bale, and then further testing will be there. But prior to that also, certain inspection that can be carried out, which is called as hand stapling or hand grading of these cotton fibers. So they will, these particular things will be understood whether this particular bull is ready for picking or not from the plant, can be plucked from the plant or not, and then further testing will be done. So likewise, these things are there. While the fiber is growing, when the bull bursts and it opens, the fibers naturally they have what are called as convolutions. So convolution is nothing but a natural sort of a twist. It is not exactly a twist, but a curliness in these fibers, which plays a very significant role in case of the technical spinning of these fibers. Conversion of these fibers into the yarn is occurring, is assisted by these convolutions. So that will be, this is a very important part, that they have naturally the convolutions. And some other things are also there, like as I have stated earlier, the maturity is there, ripening, that is the maturity of the fiber is there, etc., etc. Some different kinds of sets are there which are required to be performed. So finally grade to this required to be it is required for grading this cotton, so that it is classed into a certain particular class, or it can be attributed a certain list of properties, and these properties are which are helpful for the further spinning process on the mechanical machines. So this is how it is there. Now the convolutions play, as I have stated, very important role. Again, the fiber separation process from the seed, again it is required to be done mechanically. Earlier, priorly, people used to do these things with their hands only, but later on, with the advent of the ginning machines, the ginners are used. For example, knife roller gin or saw gin or McCarthy gin, etc. Different ginning sets are there. With the help of these ginning machines, the seeds are separated from the fibers, or we can say in other words, the fibers are separated from the seeds, and then the, depending upon, as I have stated, quality of the fibers and quality of ginning, the cotton fiber is required to be graded into a certain class. In Indian conditions, usually when the seeds are supplied to the farmers, the varieties are grown in their names. Certain names are assigned, attributed to certain seeds or certain qualities of cotton. When they are sown, a kind of a particular set of properties these fibers will have when their complete growth is there. Of course, there will be variation in this one. Now, all these fibers coming from the same seed, 2 to 3,000 fibers which come out of the same seed, even they have, each of these fiber has different characteristic as compared to the, say, neighboring fiber on the from the same seed. So that is how it is there. But still, average properties are required to be known, so that the cotton can be graded, classed, and it can be used for spinning of a particular count. Means that's why we are seeing this particular unit, that how the cotton, which type of properties are suitable for what particular count, and this is only possible either through hand grading, hand stapling, which gives a very, say, thumb rule type of an idea, but a mechanical testing of these particular properties will finally evolve a set of properties through which we can decide for what particular count these particular fibers are suitable for. Say some popular examples in our varieties in our Indian conditions are Suvin, for example. Suvin is the best long staple cotton, very high long staple cotton. Then Varalakshmi is there, or Lakshmi is there, H4, Hybrid 4, Sankar 4, S4, Wagad, Kalyan, or MECH. These MECH class A, MECH class B, etc. etc. These are some of the different fiber names. That is, different particular fibers are there. They are suitable for different particular spinning of different particular counts. So likewise, these things are there in case of the fiber. Now, these convolutions play a vital role, especially they give an assembly kind of a sense to these materials, the fluffiness, and that is very important because in groups they can be processed on drafting devices, drafting machines. So convolutions play very important role. So these different things are there, like cotton variety Sea Island is there, it will have 300 convolutions per inch, Egyptian cotton 230, American cotton 190, and Indian cotton will have 150 convolutions per inch. This is the primary characteristic which can be just assessed in the laboratory in the first instance. Now, what is a cotton fiber? This cotton fiber, as in case of the fiber definition also we have seen, this is a soft staple fiber that grows in a protective capsule known as a bull. So this particular thing, it gives, clarifies each and everything. It develops in a bull, and when it is developing in a certain period of time in a bull, one single fiber also develops some structure. Because this is a cellulose fiber, it generates a cellulosic structure inside one single fiber. So that is what is stated over here. The fiber can be spun into the yarn and used to make a soft breathable textile yarn, which is used worldwide for making of the cotton products, fabrics. That is, these yarns are further converted after weaving or knitting to the fabrics, and these fabrics are further converted to the garments. And in today's situation, where there is a thrust on ecology and all those things, these concepts are there, sustainability and ecology and green, etc. etc. These concepts are emerging. Cotton plays a very vital role in this manufacturing of these particular materials, textile materials. This is very important thing. So the classification of the cotton is done on the basis of fineness, staple length, maturity, degree of contamination, that is trash, that is the extraneous matter which the particular wool acquires when it is exposed in the environment, when the fiber is growing there, and the strength. So the fineness of the fiber is denoted by decitex. The number of grams per 1000 meter, or 1 decitex is 0.1 tex. Tex is nothing but the direct system count, grams per 1000 meter. So usually it is measured in decitex. The fineness of the cotton plays a very common role, very important role, and it is expressed in terms of micron here normally. So micrograms per inch. Normally it is expressed in indirect system. So what are the properties of these fibers and what kind of a role they play in making of the yarn, and what properties the yarn will acquire? As earlier we have discussed about this one, that yarn is an assembly structure made from these fibers. So definitely what the yarn possesses has in the bundle, that single component characteristic definitely is going to play an important role. That's why we are required to assess the properties of these fibers, and therefore we are considering here the cotton fiber properties in the which are suitable for the spinning process. Not only in making of the yarn, this actually has two dimensions. How the cotton will perform on the machine, because it is required to undergo certain tensioning, certain tension is there, certain beating of these fibers is there in different departments while it is converted from a fiber to the yarn. And at the same time, when final yarn is made, in that yarn, what kind of characteristic it will attribute to the yarn, and what the yarn will acquire the properties that will govern its downstream processing performance, and then finally how it will perform when a fabric or garment is handed over to the customer. that will be governed by this thing. So we are required to consider this one. So the parameters like fineness 1 to 4 decitex or 2.3 to 6.9 micronair of the fiber. This is very important. It is a must in general for making of simple yarns, as we have classified the yarns. In case of simple yarns, these kind of characteristics are essential. Certain characteristics are essential, certain characteristics are desirable. So fineness is an essential characteristic. Fiber length 10 to 60 millimeter, it is required to possess. Different length the fiber is possessing, different lengths are there. Actually, some different devices are utilized for measurement of the length. For fineness measurement also micronair device, the fineness measuring device is required. For measuring the length also certain devices are there. Very traditional device is the bare sorter, in which a plot is obtained and then the average length is decided, the mean length or the upper quartile length, something like that. So this is, we are discussing about the mean length of the fiber. Then density 1.5 to 1.54 grams per cubic centimeter. In case of a cotton, usually it will have this kind of a density. It will decide about the floating tendency, how it will be interacting with the air, etc., etc. That will govern this thing. The fineness will decide about how a bundle will be formed, how many air gaps will be left in the yarn. A length will decide about how much long superimposition of the fiber will be there in the yarn. That way the length is important. Then moisture regain, this is the natural tendency of the cotton fiber, which has acquired on its say own. So it is normally 8.5%. It decides about perspiration absorption, how we are going to feel comfortable when we wear a particular garment, undergarment made from cotton, etc., etc., or a garment made out of cotton, and how disposal of the moisture will be there from this particular element, that is yarn, fabric, etc. And breaking strength now, usually cotton will have 25 to 50 grams per tex or centinewton per tex. This is or 2.5 to 5 grams per denier. This tenacity, breaking tenacity will be there, bundle tenacity will be there of the fibers. Usually it is measured in the bundle. Then elongation, usually it is 8%, but a range is given 5 to 10% elongation at break. When we exceed the force applied on this material, which exceeds 8% or 10% value, then the fiber is likely to break. And that's why again this is helpful during the washing of the clothes also, that how much the fabric or garment is under strain, that will govern the long lasting or life cycle or life of that particular product. So that way it is there. In recent times, with the help of high volume instrument, we are measuring the color of the fibers, that is plus RD, the brightness, and the plus RD and plus B. So yellowishness and the reflecting tendency. These two things are measured with the help of HVR device, high volume instrument device. Different modules are there in this device which will give estimate of these different properties. Now first is prime consideration about the attribute of this particular material is how it will perform on the machine, and secondly how it will render its characteristic in the yarn. So that way the length becomes very important. Length is vital because how much superimposition or overlapping of the fibers it will allow, that will govern not only the extension at break or tenacity of this material, but at what limit it can succumb to the applied pressure. That is going to be governed by this length, and whether we can make a fine yarn out of a certain fiber or not, again that is decided by the length also. So that way the length plays a very important role. The average length of the spinnable fiber is called as staple length. Normally staple length, this term comes from hand stapling. Earlier the graders used to go in the farm, in the field, and then they used to pluck some fiber material from the bulls and then they used to measure average length after successive doubling and drafting with the hand of this fiber material, the fibers that is, and then the length was estimated. Now we can have the measuring devices as HVI length module is there, or FE's length module is there. With the help of this one, we can measure the average length of the fiber. Now for that, we are required to take this particular cotton material to the testing laboratory and then measure the length of the material. Of course, average length of the fiber, average, we are required to find out effective length, that is average length of this. Now as the staple length is more, what is the consequence of this particular thing? Actually the staple length is more, the yarn quality is better. Excellent yarn quality is obtained, going to be obtained, because when long fibers are there, these particular yarns, they can have a evenly distributed twist in them as they are required to be twisted. In unit number 1 we have seen this thing, that parallel strand of fibers twisted together to give strength. So a long fiber usually makes the yarn to have a even distribution of the twist, and not only that, a longer time will be required for the succumbing of these particular materials, because more time will be required for elongation of these materials, and thus the length will be at contributing to the quality of the yarn or ultimately the strength of the yarn. So fiber length influence, it decides about the spinning limit of the material. Longer is the fiber, better spinnable yarn, as we have just now seen. Strength is going to be higher, again that attribute we have just now discussed. Yarn evenness will be better because longer fibers make the distribution of the fibers in a much more even manner, and that's why the evenness will be better in case of them. In some very odd cases, this can become an hurdle because sometimes the lapping tendency will be there in the drafting rollers due to the length, but that can be overcome by proper setting, taking care by mechanical setting of the rollers in the drafting system. We can take care about this one. Then the luster of the product will be excellent because good reflection will take place from all the surfaces. Yarn hairiness will be less. The protruding fibers out of the yarn body, that will be less in case of this, and productivity will be much more in case of when the fiber length is more. The length grouping normally is 25 to 30 millimeters. It is treated as average length. Then short length 1 to 1 inch or less, it is short length. Medium length 1.03 to 1.13 inch, it is called as a medium length cotton. And then long length cotton is 1.16 to 1.6 inches, and then extra long cotton is 1.6 inches and above. Normally in our case, 4 classes are there, botanical classes are there of the cottons: Gossypium arboreum, Gossypium herbaceum, Gossypium hirsutum and Gossypium barbadense. Usually barbadense and hirsutum, these varieties were not grown in our country. Since the ICR, Indian Council for Agricultural Research, they have taken up this thing, and then we have developed certain long staple varieties, and then we are obtaining now the long staple materials in our cases, in India especially. Fiber fineness now. This is the second attribute. Now again, I have to repeat here, what kind of technology one is adopting. For example, some people are going for adoption of the ring spinning for spinning of the yarn from fiber. The attributes are different. When you go for rotor spinning, the attributes are different. When you go for air jet spinning, the attributes are different. The chronological order in which the properties are laid down for each of these spinning systems, I have stated only 3, but there are n number of these spinning techniques. Now in case of them, different kind of weightages are there for these properties. So one should not mix up these things. These are general considerations. This is general discussion on the importance of the properties. Once one goes for a certain technology, these attributes will take a different shape. For example, in case of ring spinning, the length becomes, say, primary, it is becoming of prime importance. Length and length uniformity of the material. When we go for the rotor, the fineness becomes the important consideration, something like that. And on an average, there is a thumb rule, you can say. On an average, there has to be 80 to 100 fibers in the cross section of any count of yarn. It is so, fineness decides that. Fineness hampers the number of fibers in the cross section. So we are required to consider this thing. Of course, alterations are made, and how these fibers are occupying their places in the yarn, and then they are getting twisted, that is governed by this fineness. So that's why the fineness becomes of prime importance. Fineness is most important parameter determining the yarn quality, as I have stated just now. How many fibers you can incorporate in the yarn cross section, and then what kind of fineness of the yarn you can produce, and how that yarn will be going to be performing in the succeeding processes, that is influenced by this thing. So it influences number of fibers in the cross section. This is 30 is very, say, lower limit. Actually one requires to be very precise. There is one particular say formula on the basis of Peirce's specific volume theory, that 15,030 whole thing divided by indirect count of the yarn any divided by micron of the fiber. So 15,030 divided by any by micron in the denominator. This is a empirical formula used for selection of number of fibers in the given yarn. This is a thumb rule. So what it decides actually, fineness, it decides the spinning limit, as I have stated just now, that a fiber becomes coarser, that is thicker, very few fibers you can incorporate in the yarn cross section. So spinning limit it decides. Then yarn strength, obviously number of fibers are less, strength will be less. Yarn evenness. Now particularly in case of the short fibers, what happens is, these are usually called as floating fibers in the drafting system when one considers the mechanical processing. In that case, what happens is, these floating fibers they are susceptible to have a unevenness in the yarn. So that is why this is very important consideration. Then drape of the fabric. Drape is how smoothly the fabric suspends itself, that is the drapeability of the material. Handle, when we touch the fabric and feel for it, what kind of a handle it gives, what luster it gives, because fiber fineness is not that much, say, fiber is not that much finer, it is thicker. Usually from its surface, the diffraction of light will take place, so luster will be dropping down. Yarn fullness, cover factor of the yarn, how that yarn appears fuller in nature, appearance, that is going to be decided, and productivity will be decided by the fiber fineness. So this is important consideration about this. Now certain values are there, micronair values up to 3.1, very fine fiber, it is called as very fine fiber or fine material. 3.1 to 3.9 it is fine, 4 to 4.9 it is medium, 5 to 5.9 it is slightly coarser, and 5.9 and above it is coarse fiber, thicker fiber. So whatever order we have seen in the earlier slide, in conjunction with that, now the length and the fineness, they are recommended by different organizations, standards organization. Like in our country, CITRA norms are there, NITRA norms are there, BITRA norms are there, or joint norms are there. On the international scene, Worcester statistics is there, which suggests that what kind of a fiber fineness you are required to choose for spinning of a particular yarn, etc. These ready reckoners are there. Now next thing is maturity. Maturity the fiber acquires when a single fiber is developing. In that single fiber, first outer surface is generated, primary wall is formed, and then inside that primary wall there are deposits of secondary wall. The cellulose deposits are there inside, these are called as secondary deposits, secondary wall. And then finally what hollow space is left inside the innermost part of the fiber, that is called as a lumen. So that decides the size of the lumen. Bigger is the lumen inside the fiber is more immature, something like that, and this fiber is susceptible to have more naps in the yarn or in the fiber lot itself. More naps are likely to be generated, and moreover these fibers, immature fibers, sometimes they are dead fibers also. So that is how this maturity plays a vital role in not only in spinning but in the downstream processing, rupturing of the material, fibrous material, or during processing also, the wet processing also, this plays an vital role. So that is how the maturity is having an impact on the ultimate fiber properties, on the yarn properties, and the succeeding products also, subsequent processes and products. So usually 50 to 80% it is there, and immature fiber represents a 30 to 45%, and a dead fiber represents 25% growth of the secondary bond. Bigger lumen is there. Now this is say depicted in this particular diagram, in this particular slide, that hemicellulose contained, then the lignin is there, and the cellulose deposits are there, and inside one can see here the lumen is there inside, innermost thing, S3, S2, S1, these are the secondary wall deposits, the primary wall is the outer wall, etc., and then the lamella is there, middle lamella is there on the fiber surface, etc. So this is how, and this is not actually as it is shown over here. Outer say cross section of this fiber is a collapsed ellipse type. A collapsed ellipse type cross section the fiber possesses. This is for the illustration purpose. In this diagram, these particular things are shown over here. So immature fiber leads to napping, as I have discussed just now. Loss of yarn strength is likely to happen because of the dead fibers or more immature fibers. Varying dye ability, that's what I was discussing, that in the wet processing, etc., dyeability or the nature in which the printing paste is acquired on this material, that will be decided. Processing difficulties, mechanical processing in the carding process in the spinning department, that will happen. Mature fibers, dye absorption will increase. Immature fibers, dye absorption will be less. Now next particular thing is consideration is strength. Now strength is usually not measured of these fibers in a single form. As I have stated earlier, bundle tenacity or bundle strength is measured. Now toughness, this is a toughness of the fiber. It is usually measured in terms of grams per tex, and it is expressed in terms of say grams per denier or grams per tex. In case usually in case of cotton, it is expressed in terms of grams per tex. So fiber strength is more, fabric strength is more, and yarn strength is obviously more because of the more fiber strength, because more contribution will be there from the fiber before the yarn gets ruptured. When the yarn breaks prior to that, the fiber contributes a lot in the yarn strength, and similar thing happens in case of the fabric also. In the fabric section, you must have seen that fabric assistance is there. So that is contribution from the yarn in the fabric. So high proportion of short fibers is there. In certain cases, the deterioration is likely to happen in case of the yarn strength, and not only that, uniformity also of the yarn will be coming down. So that way the strength considerations are there. Now whatever nominal strengths are there, in case of them, when that is observed to be 70% of that, this is to be taken in that sense. For a given particular cotton fiber, if 25 GTEX value is there, once our fiber is obtained and its value is 70% of this particular thing, then it is considered as weak fiber. And similarly 70 to 74% fairly strong, 75 to 80% medium strong, 81% to 86% strong, then 87 to 92 very strong, 93% and above excellent. that yarn has that fiber has, sorry, a very excellent strength. Now fiber cleanliness, I have already stated this thing. The fiber bull was exposed in the environment when everything was happening. The the hair was growing. Of course, inside the green pod, later on in the bull, the fiber was growing, no doubt. But still, it is exposed in the environment. So, acquired these trash particles are there, and these are classed also. There was actually earlier a device called as Worcester uh, tester 3, micro dust and trash analyzer 2 and 3, they were there from Worcester, and they were classing these products up to 15 micron. The micro dust 15 to 50 micron dust is there, then it is a dust, a fine dust, and then 50 to 500 it was called as a dust, and then above 500 that was called as a trash. Larger the trash particle size, means like sand grains are there or soil larger grains are there, they are very easy to get rid of in the spinning process, because we don't want these things in the yarn, final yarn should be cleaner. So cleanliness is required to be done in the first two processes in the spinning department, namely the bloom and card. So we are required to clean the cotton first. Of course, carding, slightly different objectives are also there, but cleaning is primarily done in these two departments. So we are required to get rid of these particular trash particles. So these different matters are mentioned over here: vegetable matters, husk portions, seed fragments, stem fragments, wood fragments, etc., or mineral materials, earth, sand, dust, coal, everything getting contaminated in the cotton. So these metal fragments, cloth fragments, packing materials, foreign matters causing these difficulties in drafting disturbance, filling up of the card clothing, contaminated yarn, etc., etc. So these dust particles, there is a certain range which is acceptable. So up to 1.2%. Normally international cottons, they will have around 1% trash. In our case, in Indian situation, this trash content is on the slightly on the higher side. So these are the statements from our own considerations. 1.2 to 2 clean. Then yarn breakages, when 2% to say more is there in case of this one, then it is a medium breakage will occur of the yarn. 7% and 4% to 7% if it is present, very dirty it can be said, and then 7% and above it is very dirty. So these varying trash containments are there in our own cottons. And finally, there are impacts, there are studies that the colors of the color of the cotton also has impact on different particular yarns produced. So that's why they are required to be measured on, of course, on the today's situation. The HVI is there, high volume instrument is there. Whether the fabric will acquire the dye or get say more dye or not, a proper dyeing will be there or not, the bleaching will be there or not of the fabric, grey fabric, that is decided from the color of the basic cotton. So that is why these measurements are playing vital role. And there are certain indices also developed by Worcester, spinning consistency index, and Citra has developed a fiber quality index, etc., etc. They give an say overall idea about the spinnability of these materials. So this is how the different properties are there of these materials. Now of course in the spinning department the different stages are there. In these different stages the fibers are undergoing different operations. In detail we are going to see in the succeeding units about this one. This is a brief outline of this one, that the fibers are ginned. Whatever the seed fibers are collected from the plant, the field, they are ginned, then they are converted into the bales. The bales are transported to the spinning mills after properly grading them. Then a certain program is required to be evolved, outlined, kept in the spinning department, which is in today's situation normally it is called as the bell management, which is given by Worcester again. Bell management or cotton mixing program or raw material management program, under these different headings these particular things come. And then after proper grading and say allocating the cottons in the warehouse of this mill, then they are taken to the spinning department, which is designated for production of a particular count. And in the succeeding stages, the cotton is passing through different processes of the textile mill in the spinning department, and then finally the yarn is prepared, and then it is further passed again through some checks, and then it is converted to a cheese or cone, and then the package is made ready for disposal to the further processing, that is winding, warping, sizing, etc., etc. Of course, in winding department the packages are prepared, yarn packages are prepared, and then further they are subjected to the weaving process or knitting process. So this is outline of this particular cotton spinning, and with special thrust on cotton spinning we have discussed in this particular unit number 2 here. So I thank you all, and then I think we have to stop here.